Next formula, find the Fourier sine and cos transform of f of x. If f of x is equal to 0 when x lies between 0 to 1, 2 minus x when x lies between 1 to 2, 0 if x is greater than 2. So given f of x is in 3 intervals, right? First 0 to 1 interval, that value is x. From 1 to 2 in that interval, its value is 2 minus x. And 2 to infinite, its value is 0. That is equation number 1. First we are going to find Fourier sine transform. We know Fourier sine transform is f bar s of p, which is equal to root 2 divided by pi integral 0 to infinite f of x sine px dx. That is equation number 2. Now we are going to use 1 in 2. That is why we are going to split the equation 2 into 3 integral, because 3 interval are there in f of x, 0 to 1, 1 to 2, 2 to infinite. So splitting that, so you will get integral root 2 divided by pi integral 0 to 1 f of x sine px dx plus root 2 divided by pi integral 1 to 2 f of x sine px dx plus root 2 divided by integral 2 to infinite f of x sine px dx. So we are going to submit the value of f of x in that particular interval. So in the first interval 0 to 1, f of x value is x, which is equal to root 2 divided by pi integral 0 to 1 x sine px dx plus root 2 divided by pi integral 1 to 2 minus x sine px dx plus root 2 divided by pi integral 2 to infinite 0 sine px dx, which is equal to root 2 divided by pi integral x sine px dx plus root 2 divided by pi integral 1 to 2 minus x sine px dx. Last one is 0. So it is equal to root 2 divided by pi integral 0 to 1 x sine px can be written as derivative of minus cos px by p. I am going to use Bernoulli's formula or integral u dv formula, right? Plus root 2 divided by pi integral 1 to 2 minus x, same one, derivative of minus cos px by p. That is equation number 3. We know Bernoulli's formula, integral u dv, which is equal to uv minus u dash v1 plus etc. etc. Here u dash u double dash are successive differentiation. So derivative of u dash, like that. And v1, v2, etc. are the successive integral of dv. So v is integral dv. Then so v1 is integral v dv, v2 is integral v1 d not dv dx, because we are in terms of x, right? So first integrand, taking the first term and the equation number 3. So u is equal to x and v is equal to minus cos px by p. So u dash, which is equal to du, which is equal to dx, that is equal to 1. v1 is equal to integral minus cos px by p dx. Minus 1 by p is constant, take it outside, integral cos px dx. Integral cos px is sin px by p. So minus 1 by p sin px by p, that is equal to minus 1 by p square sin px. Now we are going to second term. In the second integrand we are having u is equal to 2 minus x and v is equal to minus cos px by p, like above. So u dash, which is equal to du, derivative of 2 minus x, which is equal to minus 1, and v1 is same like above, minus 1 by p square sin px. So 3 implies Fourier sine transform of f of x, f s bar of p, which is equal to root 2 divided by pi. So first integrand we are using Bernoulli's formula uv. So x into minus cos px by p, that is minus x cos px by p, limit is 0 to 1. Then second one, minus u dash v1 into v1 minus 1 by p square sin px, 0 to 1. So first integrand is over. Now we are going to second term, second integrand we are taking. So that integral value plus root 2 divided by pi. So uv, here u is 2 minus x and v is minus cos px by p. Limit is 1 to 2. Minus u dash minus 1 and v1 minus 1 by p square sin px 1 to 2, right? Now we are substituting upper limit and lower limit. So upper limit, first term 1 cos p1 by p plus 0 cos 0 by p. Second term 1 by p square sin p into 1 minus 1 by p square sin 0. So next we are going to second one, root 2 divided by pi, upper limit 2 minus 2 minus 2 cos 2p by p plus 2 minus 1 cos p into 1 by p, right? Then second term minus 1 by p square sin p into 2 minus 1 by p square sin p into 1, lower limit, upper limit. So we are simplifying root 2 divided by pi. So first term minus cos p by p plus cos 0 into 0 0 sin 0 0, so remaining term 1 by p square into sin p. Second term plus root 2 divided by pi, so 2 minus 2 0, so total term 0, so 2 minus 1 1 into cos p by p, so cos p by p. The second one minus 1 by p square sin 2p minus 1 by p square sin p. So minus root 2 divided by pi multiplying with each term cos p by p. Then the second bracket, right? So you are having root 2 divided by pi first term cos p by p, right? We are writing that one. Then plus root 2 divided by pi 1 by p square sin p in the first term, second term. The first bracket, second term, right? Now we are going to the second bracket, root 2 divided by pi. In that we are having 1 by p square sin p, because in the second bracket third term minus into minus, outside you are having one minus, so minus into minus plus, so 1 by p square sin p root 2 divided by pi. Then remaining minus root 2 divided by pi 1 by p square sin 2p. So here first two terms get cancelled, so remaining third term and fourth term same term, so grouping that 2 times root 2 divided by pi 1 by p square sin p minus root 2 divided by pi 1 by p square sin 2p, which is equal to root 2 divided by pi 1 by p square common, so 2 sin p minus sin 2p. We know sin 2p which is equal to 2 sin p cos p, we are using that trigonometric formula. So minus 2 sin p cos p. In that 2 sin p is common, take it outside. So we will get Fourier sine transform of f of x which is equal to fs bar of p, which is equal to 2 times root 2 divided by pi 2 sin p by p square, so 1 minus cos p. Next cos transformation we'll see on the next video, right? Thanks for watching.